Oh, thank you to be here for this talk about like configuration management with Kubernetes. I know that Kubernetes like is super popular, but it is a Spring Boot conference, so I will try to apply the Kubernetes recipes to Spring Boot. I'm Nicolas Frankel. This is actually my second Spring I.O. I was there like 2 or 3 years ago, I don't remember. I've been doing consulting work for more than 17 years in the as a Java developer architect position, and 6 months ago I decided that it was much better to be paid to go to conferences, do talks, have beer, meet people. It's a good way to earn money. I've always been interested about like what is beyond the wall. You know that there is a dev and the ops space, and if you are who here is a developer? Okay, nearly everyone. After you create the package, then it's not your problem anymore. You send it afterwards, and whatever happens, happens. I don't know why I was always interested in what happens afterwards. So my first talk here, like in the previous edition, was about the Spring Boot actuator, which is a very super nice piece of engineering, and today it will be about Kubernetes. I work at a company called Exoscale. We are a European cloud provider. Who doesn't use the cloud yet? Everybody does. Who is using the cloud? Who is using Amazon? Yeah. Google? Yeah. Azure? Microsoft Azure? Yeah. So all those nice companies, they are American company, and who knows about the Cloud Act? A few hands. And of course, less than all who use the cloud. So the Cloud Act is a US law, but which applies worldwide, just like GDPR, but reverse. And it tells you that if you contract with an American company, the US government can access your data anywhere in the world. Even if you contract here, hey, my data center is in Barcelona, whatever. If you value the data of your customer, if you value your own data, I encourage you to look at the Cloud Act to understand what it entails, what the consequences are, and to check European cloud providers. Anyway, so this is what you can find on Wikipedia about configuration management. So it's a super nice piece of text telling you, well, very general terms. In general, when you think about configuration management, you think about those. And of course, the first step of configuration management is scripts. You try to make your life easier by creating scripts. But for 1 machine, for 2 machines, for 5 machines, it might work. After some point, however, you notice that that doesn't scale, because then you have a lot of machines. And now we are in an era where we don't have like server as pets. We have kettles. When something doesn't work, we kill them, we relaunch them, and we want to make sure that those are the same that were before. I remember some years ago, something happened in production, and though we deployed to like pre-production before, we didn't notice it. And then my question, but why? I mean, the environment was supposed to be the same. But of course, it wasn't. You couldn't do manually keep your configuration like the same. And so there are like a lot of new tools like Puppet, Chef, SoulStack, Ansible, whatever, that are supposed to do that for you. Who here is a configuration management user? Not that many people. Puppet, Chef, Ansible. That's funny. Okay. Now, I always had a problem with Ansible, because once I understood Puppet and Chef, it was very hard for me to get back to like typing commands. Because what you do when configuration management is that basically you you describe, you declare the state of the system. You want the system to be in, and then you trust the configuration management tool to keep that system in this state. And of course, your system will drift. And then it's the role of a configuration management tool to always like push it back to where it was. That's what the power of a like declarative configuration management is. And now comes Kubernetes. And you don't have those problems anymore because you have immutable images wherever you are using Docker or not. Images, they are mutable, so they are not supposed to change. So what's the point of configuration management in that case? The problem is the same image needs to be deployed in different environments. So even if the image is immutable, it should be configured in different ways. Like before, you had the war, and you deployed it into Tomcat. And of course, if you deployed it in development environment or in like staging environment, the database URL was not the same. So though your war was immutable, you needed to configure in some way. And for that, if you used WebSphere or Tomcat, yeah, some people used WebSphere, believe me. Well, you could configure the symbolic link to a real data source, depending on your environment. There are still a few seats left here, if you don't want to stand. No, you want to stand. OK, that's fine, too. So we have the same problem with Docker images. We want them to be immutable, but we still want them to be configurable depending on the environment. And for that, there is a very simple use case. You deploy your application in different environments. And then you are on the test environment, and you want to reset the whole database because you want to run your tests. So you go to the application, you remove every user, depending on the user interface, and then you notice, hey, I was on production. It never happened to you, right? So previously, how we addressed that, and probably you still do, is that depending on the environment, you have a banner with the name of the environment on top of it. Who does it already? So I guess all the others, they don't. It's a good idea. Think about it. So in production, of course, you have no banner. It's the good stuff. But then in every environment, then you have this banner and the name. And that's a perfect use case for us, because then we have the same application and we deploy it to different environments, and then we get that. So I've talked enough. Now let's do some demo stuff. So I've created an application, existing application on start.spring.io. I have a simple controller that redirects me to a TimeLift template, and on the TimeLift template, I get the label and I get the color. And if the label and the color, I show them. If there is no label and no color, of course, I don't show anything. So I will just show you how it works without any profile or anything, just out of the blue. Yes. Start the stuff. And then I can show you how good a designer I am, and then you understand why I'm a backend engineer. See? Very great. That's basically what I want to have in production, but then in different environment, I want to show something else. So one of the easiest way to achieve that is basically to create profiles. I want to create profiles, and so I have a dev profile, and when this profile is activated, I want to have the yellow development banner, and when this is activated, I have the staging orange stuff. Okay? So let's try it. So you might know about Spring Boot. The first thing to do is I will get the environment. So private environment, and I will make it final. And then I can get those keys app.env.color. And label. And then I pass that to the model, right? So normally what should happen here? Yeah, I'm sorry that it's a session where you should work. What happens now? Thanks. Nothing happens. Nothing happens, which is what I want because it's the default profile, it's production. So now I will activate the staging profile, and normally, I didn't check, I hope I checked the stuff here. It's dev profile. Yep, so it works. Hey, easy peasy, it's done. However, you might object that, hey, getting the environment, it's not super great because then we get the whole stuff. So perhaps it might be better to have like individual keys. So this can be done also by annotating and injecting, not value, color, like that. So here I will just copy paste that. And label and label. And normally, if I reset that, I will change to have like staging just to make sure that it's not a cache or anything. Yep, it works. But, I mean, it would be hard to test. If I want like to have like an integration test, I need to get the hold of a private field. So injecting by field is not super great. So one of the other option that we have is to create like direct properties. So I can create a dedicated class and have create application environment properties. And then I don't remember the name. It's config props. Yes. So here, with a class, I just mimic the structure of the YAML file. And then automatically, magically, and of course, because I annotated them, then at startup time, like Spring will read the YAML file and will put the values into this class. So now I just need to get back to my like private final application environment properties, props. And I can do dot props dot get env dot get color. No, not get class, get color. And same here, props dot get env dot get label. And here, I only have the values that I need in a neatly injectable class so that you can like integration tests wherever you want. And now it works again. Great, perfect, everything is fine. Now we have something that works. How do we do that with Kubernetes? Well, the first thing to do is actually to create the deployment file. So I will create a new YAML file, cates deploy.yaml. And here I will like create very easily my deployment. I'm so fast, yeah, I know. So first I will create a namespace because like you do your code in packages. Here I create my deployment in a very specific place. So I create a namespace. And the second section is about the service, because you know that by default, whatever happens inside a Kubernetes cluster stays in the Kubernetes cluster. Yeah, you knew about Las Vegas, but it's the same here. So if you want to access the Kubernetes cluster, you need to give like an entry point. And there are several entry points available. The easiest one to use, at least for testing, is not port. So that means that I will give the IP, the local IP of the Kubernetes cluster, and this port number, and I will be able to access the single pod inside. And finally, I have a single pod, which is good enough for our needs, and I deploy my application. But so far, I don't have any container to deploy. I just have like my application. For that, what you can do is you can add the Gib plugin, and I encourage you to look at the Gib plugin. It's really great. It's a plugin made by Google, and you don't need to create a Docker image. The Gib plugin takes care of it for you. So it will just check the main class, and out of the main class, it will create the Docker image with all the required jars and all the compiled classes and all the resources. That is super, super great. And you have like two goals available. The first one is basically you push your image to the registry. So by default, it's the Docker Hub registry, but you can configure it with credentials and blah, blah, blah. Or here, what I will be doing, I will just be sending it to the local Docker daemon, which means I don't have a round trip to push and then to pull. Very, very useful. As you can see, it's just like the classes themselves and the jars that are Dockerized. I don't create a jar out of the application. So now, normally, if I Docker images grep config mgmt mg config and it's taking ages. I don't know why I have a trouble with that. Sorry? Okay, let's forget. Believe me, they are here. So what I want now, I want to deploy it. So I will be deploying it. And to deploy that, to schedule that, because in Kubernetes you schedule images on pods, I will apply the file that I've just created. And the namespace was already created. The service was like already created. The only new thing is the application. And now I have my application running on Kubernetes. And I just need to get the IP. So I'm running on Minikube. So I need to get the IP of Minikube. And as I told you, I just need to there is 1 0 too much. Here. Okay? So now is how do I get my banner if necessary? Well, we have created profiles. So let's use the profiles. And actually, inside of IntelliJ, the profile is just a checkbox. But normally, the profile is just like an argument, an additional argument to the command line after the main class. So to do that, we will do exactly that. We will just do like, no, because I'm lazy. I already prepared everything here. So I will add an additional argument to the command line, just as Jib would do it. And now, so here I must remove the existing pod because I didn't use any fancy stuff. So kubectl let delete pod and okay, it's deploy. So no, delete pod, sorry. Delete pod application, of course. So now it removes the pod and it deploys another one. So we can check that everything is still fine. Yes, it's running again. And now we have the banner. So we have one single immutable image, and then it's very easy by passing the profile as an argument to be like context dependent. And it might be good enough for you in most cases. But the problem is what happens if you are working for a company that spins environments often. If your number of environment is small and stable, doesn't change so often, that's fine. But every time you build a new environment, you create a new environment, that means that you need to create a profile inside the image. That means that even if the image doesn't change because of the code, you will need to create a new release to have a new profile. So a new version for something that doesn't change. It makes no sense. So another way to do that is actually to use system properties. So instead of using profile, what you can do is you can like pass the values directly as system properties. Just let's try that locally first. It works. So basically, we just need to change the arguments, right? Yeah, remember, you need to work a bit. So, right? No. No, because actually the arguments, they are after the command line. The profile is after the command line. But if you want to pass system properties, they should be before the main class. So that means that you need to know about the Jib command line and to override it. So it's possible, but not super nice. It's possible. Yeah. Hide your happiness right now. So now it should work. I did like purple and pre-production. So now if we go on Kubernetes cluster, purple and pre-production. So this might be good enough for you, but actually Jib was a nice abstraction. We didn't care about what it did, about the command line, about the class path, about whatever. Now we need to understand what the Docker image looks like and to do stuff that is below the abstraction. Now we need to get our hands dirty. Who likes it? Yeah, it might be good enough for your needs. That's perfectly fine. Let's see what we can do. Actually, you might know that you might not use system properties, but environment variables instead. Then we don't have any problem with the command line anymore. Cheers. Too soon. No. Hey, there is always a demo effect. So it works, and much better, because now we keep the abstraction. But yeah, I'm sorry, I stepped on my glasses. So basically, below the first line, I see only a blur, and you are just sitting in the front row. So I need to address to someone. Huh? I mean, wasn't staging supposed to be a range? Oh, you don't remember already. Well, the problem with that is basically if like variables, parameter, or whatever you call them are dependent on each other, you might do this kind of mistake because whatever happens, happens. So it would be great if we had again, an abstraction, a map, a data structure to put all the variables that what we need into a single place. And that's good, because if you know about Kubernetes, there is something called configmap. And configmap basically is just that. It's just a map, key value pairs, with a name. And then you can reference this map from your container. So instead of having env, we have something called env from. And so we get those environment values from a config map. So now we are nicely isolated, and I need to run it because otherwise you won't believe me. We are again, we keep our jib abstraction layer. We are nicely isolated, and we have our environment in one single place that we can reference, and which has a semantic name. Huh? It's called STG, so we know it's staging. You cannot make mistakes about that. Well, you always can, but let's say you reduce the probability. Back again. Who is happy with that? Yeah, I'm also quite happy. But now you must think, okay, but who is creating the maps and updating the maps and creating new maps and stuff? And perhaps in your company, sorry, there is a Kubernetes administrator and there are developers, and perhaps they don't share the same access rights. They have different life cycle, different ways of working. Well, let's say it in one word, you are not DevOps. So perhaps you want to leave to the developer a way that they can update those values without managing Kubernetes at all. So let's remove the config map. Let's put that in comment because I will need it later. And what we can do is we can say, let's put those values into a Git repository. And Git repository, this is a realm of the developer, so they can push whenever they want. Now it becomes a bit more complex, but only marginally so. Here, I've created something called a an init container. And by contract, the init container will run successfully before any of the image in the pod will start. Of course, if the init container fails, then nothing will start. It can happen. But if it does, then that means that whatever you did, you can be sure in your container that you can rely on it. In that case, I mean, yes, it's a long command line, but believe me, I just do a git clone of a repository, of a Git repository, and I put the stuff into a config folder. And because this config folder is mounted to a command volume, here, and here, what happens is that the content of the Git repository will be accessible in my application's image. And it can use it. And because I mapped it and it has like a format that Spring Boot knows how to read, because you know that it can read stuff from /config. So not only environment variables, not only system property, not only profiles, but also like files that are supposed to be in a /config folder. Then Spring Boot can use those files. So let's try it. I don't trust it. It's not scheduled yet. Yes, it does. Still works. But now you might say, okay, but I might want the same mechanism, but I want to be parameterized. Then we can use the configmap from previously. Clone props. I will just use here. No, not that, that. And here. So I've added an additional layer of abstraction so that now my config map doesn't hold the value, but just the environments and the version. And of course, for that, I need to pass it here. Who loves YAML? Okay, who hates XML? I don't understand that. Really? I mean, YAML is a Python of configuration files. If you forget one space, you are, yeah. Here, I'm super happy to have IntelliJ to tell me, no, you did something bad. Otherwise, and here I must have this one. Really, you don't like XML? I mean, it has a grammar. JSON, no grammar. YAML, oh, fucking no grammar. Must be too old. And let's check that it has been deployed. Yes, it has been deployed. And it still works. So normally here, if we change the value, because I just want to make sure that everything works, if I do dev, and I keep the version because I have only a single version, takes a bit of time. Yes, I love it. Yes. Yeah, I've been a consultant, but I'm not bullshitting you. It really works. It's not a whiteboard. So basically, we have seen multiple ways to initialize and to configure your Docker image that contains a Spring Boot application in a Kubernetes cluster. The easiest way is profile. No doubt about it. Profile is the easiest way. However, if your environments, they are not stable, they change a lot, you must spin off on new environments every now and then, it's not the right solution, because then you will need to update the image, and that's what you don't want to do. What we have seen afterwards is, perhaps it would just be easier to add system variables, system variables, system properties, sorry. But then you need to know about the way that Jib launches your image. And then you need to like duplicate it, and then you need to change it. It's not super comfortable. You lose the abstraction. The third way we have seen is we can use environment variables. It works pretty well. We get the abstraction again, but you might mismatch if values are dependent on one another. You might mismatch them, and you will do mistakes in that case. And of course, the whole point of this is like to avoid mistakes. Then we have seen that you can put everything that is related into configmap. And again, that might work for you if you are in the DevOps setting. But if you have like very separated roles, if your developers don't have access to that, then in that case, perhaps it's better to have an init container. And the contract of the init container, again, is like you are sure that it has run successfully because you start your other container into in the same pods. We have used a Git repository for that. And then we can go the whole 9 yards, like we add, again, a config map to parameterize some of the Git command that is run. And at the end. So you can read about my blog, you can follow me on Twitter, you can, of course, get the repository and work it out for yourself. And on every step, I have a commit, so you can see what is changing between two commits. And if you need to remember all I told you, then I've written a nice article for you that goes into the same details as I've told here. So now we have like 10 minutes for questions, and I will be happy to answer them. Yeah, there is one question. Oh, there are so many questions. The gentleman, he has a mic already.
Hello. So question is, how is your approach better over using Spring Cloud config server?
It's another option. It's a complete different option. Basically, what I could have done here in one of the options is basically to use Kubernetes with a init container to use Spring config server. It depends. With Spring Cloud config, which I must admit I never used, basically you don't need to use Kubernetes. You use your own stuff. My approach is, and it's not my approach, it's my approach is not better. It's just that I give you a whole palette of possible choices, and depending on your context, on your use case, on your company, on what you like and you dislike, and what works for you and not, then you can choose whatever you want. If you use Spring Cloud config and you are happy about it, then everything is fine. There was a question here. Here? Thanks.
Changing the values in runtime. Changing the values in runtime in the Git repository does reflect in our Spring application or not?
So no, those values are not hot reloaded. So if you change the values at runtime, you will still have the same stuff. What you can do, however, is you can like restart the container when Kubernetes detects a change. So through a dedicated Kubernetes container, you can watch that the values are changed or not. And then you can like stop the pod and restart a new one, or start like changing your replica set if you're using replica set or deployments or whatever. If you want to bake that into Spring Boot, I don't know how it can be done. I don't know how it can be done. It's interesting, but probably you can like catch Stefan Nicole or the team. They probably know about it. What I know is from the Kubernetes point of view, you can like watch the changes and restart the pods. with the new values. And if you have deployments, you can do that in a rolling update, so that's fine too. You have no downtime.
Okay. And how do you handle passwords?
There is a dedicated config map called secrets.
Okay, thank you for the presentation. You're assuming at any point that there's a dedicated Kubernetes file per
There
environment.
is a dedicated, sorry?
Kubernetes file
Yes.
per environment, because obviously you have the environment in all the options that we have seen, but it's in that file.
Mm-hmm.
So I've seen other alternatives, like I have one single Kubernetes file, I bake the image, and the image has the properties per environment. Okay, so another option with this that you have presented, I think, is that using Helm charts in order to have templates of the environment. So at the end, you have the same file that you have, but in a Helm charts manner, and the environment, it's a Helm variable, no?
Yeah.
So then you only manage one Kubernetes file.
There are multiple ways to handle this configuration file.
Mm-hmm.
This was not the theme of this talk, and to be honest, I have seen so many ways to do that, and it seems the community hasn't found the real good way to do it. So I don't assume that there is a single file. Here in my demo, it was much easier to have one single file, but you could have the namespace in one file, you could have the service in another file, you could have the pod in a third file, you could have one pod file per environment, you can do whatever you want. I have no real good advice to tell you, but wait until there is a consensus somewhere. Let's face it, Kubernetes is very early in its life cycle. There are a lot of stuff that we need to understand how it works, and basically we learn by failing. So right now, I didn't fail enough to tell you, hey, this is how you should do it. I've seen Helm charts that are so parameterized that basically you don't understand nothing afterwards. Then there is customized, but don't take the fact that I put everything into the same file for the way you should do it. It was just only for demo purposes, and then it's very nice. Then I push on Git, you have everything in one file, you can see everything. Other questions? Everything was clear? Aye. It's lunchtime, right? Okay, thank you very much.
Hi.